Hello, friends. Welcome to online lecture series of discrete mathematics. In our last session, we have studied what is complete graph, what is a regular graph, what is a bipartite graph, right? So now today we'll see what is a complete bipartite graph. So before we start with the complete bipartite graph, so for this complete graph, so you have to remember a formula for this complete graph. So whenever there is a complete graph is there, then number of edges for the complete graph are n into n minus 1 divided by 2, right? So number of edges in a complete graph is equal to n into n minus 1 divided by 2. So see here, suppose this is your complete graph, right? So here, how many vertices are n is nothing but the number of vertices. So 2 into 2 minus 1 divided by 2. So this 2 gets cancelled. So it is 1. So number of vertices are 1. So number of edges are 1. So see here, there is only 1 edge. For the same here, second example, this 1, 2, 3. So equal to number of edges is 3 into 3 minus 1 divided by 2. So 3 minus 1, 2. So 3 into 2, 6. 6 divided by 2. So that is equal to 3. Number of edges are 3. So here 1, 2, 3. So this is the how to find out the number of edges in a complete graph. That is n into n minus 1 divided by 2. So next, that is a complete bipartite graph. So graph V comma E is called as a complete bipartite graph. We know the bipartite graph. In bipartite graph, a vertex V is partitioned into V1 and V2. So same here, the vertex V's can be partitioned into two subsets as V1 and V2. But only difference is here. That is each vertex of V1 is connected to each vertex of V2. So whatever subsets, right, are created, that is V1 and V2. So every vertex of V1 is connected to every other vertex. So every vertex of V2, right? So number of edges in complete bipartite graph is m into n. Is m into n. So that is number of edges in bipartite graph is m into n, and number of vertices is equal to m plus n. So this is examples of a complete bipartite graph. So these are the three. This is V1, V2, V3. So this is V1 in V1. That is V1, V2, and V3. Right? Second, V2. So subset V2 containing U1, U2, U3, and U4. So see here. So as per definition, right? So V can be partitioned into two subsets V1 and V2. So every vertex of V1, V2, V3 is connected to every vertex of V2. So V1 must be connected to U1, U2, U3, and U4. See here. This V1 is connected to U1, U2, U3, and U4. Same V2 is also connected to U1, U2, U3 and U4. Same V3 also connected to U1, U2, U3 and U4. So this is a complete bipartite graph of K3, 4. So number of vertices are 7 and number of edges are m into n, that is a 12. 3 into 4, 12. So see here 12 vertices 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number of vertices are 12. So 4 into 3, that is a 12. Sorry, number of edges are 12, not vertices. Number of vertices are that is 7 and number of edges are 12. In second example, same here V1 containing only one vertex, that is A1, and V2 containing B1, B2, B3 and B4. So every vertex of V1 is connected to every vertex of V2. So A1 is connected to B1, B2, B3, B4 and B5 also. So this is the complete bipartite graph of K1, 5. Number of vertices are 6 and the number of edges are 1 into 5, that is 5. It's 1, 2, 3, 4, 5. So number of edges are 5. So this is your complete bipartite graph. Next, Euler path. So Euler path through a graph is a path whose edge list contains each edge of the graph exactly once. Exactly once. So for Euler path, you have to travel every edge of the graph exactly once. Euler circuit is a path in which initial vertex appears a second time as a terminal vertex. Meaning Euler circuit, you have to travel each edge exactly once, but here first and last vertex are the same. That is, initial vertex appears as a second time as a terminal vertex. Euler graph is a graph that possesses Euler circuit. Euler circuit uses every edge exactly once, but vertices may be repeated. So this is example of this, right? The graph shows is a Euler graph. So we were to find out the Euler circuit. So in the Eulerian circuit, the first vertex and last vertex are the same. This initial vertex appears as the second time as a terminal vertex. So whenever we start with V1, here for Euler, you have to travel every edge exactly once. Every edge exactly once. So V1, V2, V3, V5, V2, then V4, V7, V10, V6, V3, V9, V6, V4, V10, V8, V5, V9, V8, and at last V1. Means here you have to traverse every edge exactly once. Means but vertices may be repeated. So next, that is Euler theorems. Euler's theorems. So what is this Euler's theorems? The consider any connected planar graph. So what is this planar graph? We'll see in the next session. So having R regions, V vertices and E edges. So the theorem containing this V plus R minus E is equal to 2. So V is the vertices, R is the regions and E are the edges. So V plus R minus E is equal to 2. So for this graph, see it. This is your graph containing the 2 vertex and 1 edge. So V is equal to 2, R is, right, 2 vertices, region. Region, what is a region? Right? So this is one region, only a region. So whenever we consider region means what? is a part. Suppose this circle. So this is one region, and outside of this circle is another region. Right? So again, suppose this is a triangle here. So how many regions are here? One, this is second, and this one is third. So region means also we can cut that graph into a different pieces. Right? So here 1, 2, and 3. So there are 3 regions. So here for this a graph, here V number of vertices are 2, this one, and this one is 2. And number of regions are only one, is one region. So 2 plus 1 minus 1. So 2. This. So here V is equal to 1, R is equal to 2 for this graph. V is equal to 1, right? Vertex is 1, regions are 2, this is one region, and outside is second. So there is 1 plus 2 minus 1, that is 2. That is 2. So this is Euler's theorem, that is V plus R minus E. So when you have to find out edges here. So E is equal to V plus R minus 2 also. As V is a number of vertices, 2 plus 1, that is 3. 3 minus 2, that is 1. So we can modify this Euler's also, Euler's theorem also, that is V plus E. So V plus R minus 2 is equal to V plus R minus 2 is equal to E. So V is equal to 2 plus 1 minus 2. So number of edges are 1. See here, number of edges, this one, it's only 1. So we stop here. In next session, we will see the next part.